Hello, I'm Professor Ken, and I'm here today to teach you about problem set number 27. So by the end of this video, you should be able to do problem set number 27 just fine. Let me share my screen. Okay. And turn off the video so that my looks don't get in your way for your learning. Slideshow from the current slide. All right, so today's problem set number 27. All right, so just a little review of implicit differentiation. When we have x's and y's that are together on one side of the equal sign, we want to use implicit differentiation. And the step-by-step procedure is to take the derivative of the right side and the left side simultaneously, but don't forget your dx's and your dy's. That's really important. Then we're going to add and subtract to get everything with a dy on the left side of the equal sign. Then we're going to add and subtract to get everything with a dx on the right side of the equal sign. Then we'll factor out our dx's and our dy's, and we'll divide everything by dx, and then get everything else on the right side of the equal sign. So dy over dx is all by itself on the left side. And we'll circle our answer. All right. If you have any questions from problem set number 26, which is due today, please email them to me, and I'll email them back with great explanations and visuals. All right, by the end of today, you're going to be able to take the derivative of e to the x, which you should be able to do already anyway, a to the x, something new, e to the f of x, something new, and a to the f of x, something new. We're also going to review logarithmic differentiation. So to activate prior knowledge, log base b of f of x, we learned this in the last class, is f prime of x over f of x times the natural log of b. We call that dividing by the natural log of b part the adjustment. All right, so what would be the derivative of 7 to the x? Well, we don't know how to do that, so we're going to set everything equal to y and use logarithmic differentiation. So the next step would be to take the natural log of both sides. Now, when we do this, we can throw the x out in front by using the first law of logs. And we can recall that x times the natural log of 7 is the same thing as natural log of 7 times x. So its derivative of x is just 1. So it'll be natural log of 7 dx. And over here, the derivative of natural log of y is 1 over y dy. So 1 over y dy equals the natural log of 7 times dx. Now we're going to divide both sides by dx and multiply both sides by y. You're going to hear me say that a lot today. Divide both sides by dx, multiply both sides by y. Now we can't leave y in our final answer, even though dy over dx is isolated. So look, y equals 7 to the x, so we'll replace it. And there's our final answer. So the derivative of 7 to the x is 7 to the x times the natural log of 7. Circle. So let's generalize. If the derivative of 7 to the x is 7 to the x natural log of 7, then what's the derivative of a to the x? We'll just replace the 7 with an a, so it would be a to the x times the natural log of a. Awesome. Now let's take a look at what we learned so far. We've learned the derivative of e to the x is e to the x, and we've learned the derivative of a to the x is a to the x times the natural log of a. And remember, the derivative of natural log of x is 1 over x, so the derivative of log base b of x is 1 over x, natural log of b, we call that the adjustment. We'll be doing some adjusting today too. All right, now we're going to take this derivative, which is really just the chain rule. So the outside function is e to the inside function is 3x to the 7th minus 4x. So the derivative will be e to the 3x to the 7th minus 4x times d inside 21x to the 6th minus 4. But we're also going to do it logarithmically. So we'll take the natural log of both sides. Now, natural log of e to the cancels out, so we're just left with 3x to the 7th minus 4x over there. Now we can take the derivative of both sides. The left side is 1 over y dy. The right side is 21x to the 6th minus 4 dx. All right, I'm going to say this. You heard me say this before. I'm going to say it again. Divide both sides by dx and multiply both sides by y. All right, and what does y equal? E to the 3x to the 7th minus 4x. So replace the y with e to the 3x to the 7th minus 4x. And there's our answer. Circle it on up. get this out of the way. Let me try to get this out of the way for a second so I can go back because I think I covered up the answer. There we go. Okay, here's the answer. We replace the y with e to the 3x to the 7th minus 4x. All we did was made a change there, exchanging equals for equals. So there's our final answer. All right, so let's generalize. So we just learned that e to the 3x to the 7th minus 4x is equal to e to the 3x to the 7th minus 4x times the derivative of the exponent. So what can we say about e to the f of x? Well, it's going to be equal to e to the f of x times the derivative of the exponent, f prime of x. So what have we learned so far? That the derivative of e to the x is e to the x. That the derivative of a to the x is a to the x times the adjustment natural log of a. And the derivative of e to the f of x is going to be equal to e to the f of x times f prime of x. It's kind of a combination of these two. No, it's not. It's chain rule. All right, and now we'll do the derivative of a to the f of x. Okay, here we go. So let's start with 7 to the cotan x. Now, you should know, but I'm going to remind you, the derivative of cotan x is negative cosecant squared of x. So we'll start here with y equals. We'll take the natural log of both sides, and we'll use the first law of logs and throw cotan x out into the front. So we end up with natural log of y equals the cotan of x times natural log of 7. We'll put natural log of 7 out in front because it's just a coefficient. Natural log of 7 is a whole is a number, a real number. So when we take the derivative, we'll just bring it down. So the left side is 1 over y dy. The right side will be natural log of 7 all times negative cosecant squared of x dx. Okay, now once again, divide both sides by dx, multiply both sides by y. Don't have any room, so I'm going to bring it over here. And what does y equal? 7 to the cotan x. So we'll replace this y with 7 to the cotan of x. Now I'm going to rewrite this. See, we have c times b times a. I'm going to write it as a times b times c. And there's reason for this, but we'll circle our answer. And I'll show you why in the next slide. It helps us generalize. All right, so we have the derivative of 7 to a function was equal to 7 to that function times the derivative of the function times the natural log of 7, which is the adjustment. So the derivative of a to the f of x will be a to the f of x times f prime of x times the adjustment natural log of a. And there we have it. So that's our fourth proof. So what do we know so far? Derivative of e to the x is e to the x. Derivative of a to the x is a to the x times natural log of a. Derivative of e to the f of x is e to the f of x times f prime of x, which is just a chain rule. And the derivative of a to the f of x is a to the f of x times f prime of x times the adjustment natural log of a. So if we have a to the x, we've got to add on the adjustment. That's it. Okay, now let's move on. Let's try one. Okay, we're going to take the derivative of 58 raised to the 5x plus sine x, all raised to the e. So this is chain rule. This is just a number. So we're going to use the power rule by throwing the exponent out in front and subtracting 1. Then we'll have to do the derivative of 58 to the 5x plus sine x, which would equal 58 to the 5x plus sine x times the derivative of the function 5 plus cosine of x times the adjustment natural log of 58. So look at what we have. We took the e, put it out in front, brought our whole function up, and subtracted 1 from the exponent. Then we do the derivative of the inside, which is 3 parts. The first part is what we started with. The second part is the derivative, 5 plus cosine of x. And the third part is the adjustment, natural log of 58. And that's all there is to do. Nothing else. Big old circle. Take a look at this. All right. This is a scary function. So you know what we call this? Too scary to use the power product and quotient rules all at once. So what happens if we take the natural log of both sides? We use the laws of logs. It becomes a lot easier, and we call this logarithmic differentiation. So what's the step-by-step procedure? So first of all, oh, so I had something. Okay, so first of all, look, I took the natural, so y equals x cubed cosecant of x over log base 2 of sine x. Now keep in mind, the derivative of cosecant of x is negative cosecant x cotangent x. You're going to have to remember that. So if I take the natural log of both sides, I have, using the laws of logs, because we have to train our brain, use the laws of logs. This would be 3 natural log of x plus natural log of cosine x minus natural log of log base 2 of sine of x. All right, derivative of natural log of y is 1 over y dy. Derivative of 3 natural log of x is 3 over x. Derivative of natural log of cosecant x is the derivative of the inside over the inside. So it'll be negative cosecant x cotan x over cosecant of x. And then minus, okay, how do we do this one? It's the derivative of the inside, which will be the derivative of this little guy over that times the natural log of 2. So the derivative of the inside would be cosine x over sine x natural log 2. And then all that is over the inside, log base 2 of sine x. So we have cosine of x over sine x natural log of 2, and all of that's over all of this. So it's a chain rule in a chain rule. Now what are we going to do to both sides? Divide both sides by dx, multiply both sides by y. Oh no, not yet. Clean it up. Oh, I forgot my dx here. I really should have parentheses here. And a parentheses here. So we took the natural log of both sides. Now we took the derivative 3 over x times the natural log of cosecant would be negative cosecant x cotangent x all over cosecant x. We see they'll cancel at some point. And then this will be our denominator, which is right here, times the derivative of this is cosine x over sine x natural log of 2. Right, now, cleaning this up, all we do is we take this sine x natural log of 2 and we drop it down to get rid of the complex fraction, which is the same thing as changing the main division bar to a division sign. It's the same thing. So just take this line and drop it down. Sine x natural log of 2 times log base 2 of sine x. Okay, now we're going to divide both sides by dx, multiply both sides by y. Notice I didn't cancel those out. I probably should have, but I didn't. Okay, and the last step we're going to do now is to replace the y. So we see that y is equal to x cubed cosecant of x over log base 2 of sine x. But take that y out and substitute equals for equals. And this monstrosity is our final answer. Okay. So the steps to logarithmic differentiation that we just did. Step 1, admit that it's too scary to use the power rule, chain rule, and quotient rule all at once. Take the natural log of both sides. Use the laws of logs to rewrite the right-hand side. That makes it really easy to take the derivative. Take the implicit derivative of both sides. Divide both sides by dx and multiply both sides by y. We've done that 100 times. And then take the y out and substitute back for its initial value. Circle your answer. Okay, let me stop the share. And we now are masters of taking the derivative of power functions, e to the x, e to the f of x, a to the x, a to the f of x, as well as logarithmic differentiation. So this is Professor Ken signing off. If you have any questions about problem set 27, shoot me emails. I'll write you back. All right. Thanks, everybody. Bye-bye.